Now, this Hurricane Hunter airplane has a real need for ice and rain protection. But most of the time, our needs aren't quite that heavy a duty. Let's start off talking about, first of all, carburetor ice. Now, when are you most likely to have carburetor ice occur? Well, it can occur in warm weather, even when there is no visible moisture present. Carburetor ice, unlike a lot of other forms of icing, does not have to have visible moisture present, and you can even get it in warm weather due to the temperature drop as the air goes through the carburetor. So, how do you eliminate carburetor icing? Well, one way to eliminate it is by using carburetor heat. By heating the induction air as it goes into the carburetor, that heated induction air will eliminate carburetor icing. That's one way to eliminate it. And another way is by using alcohol spray. Alcohol spray is used on the larger reciprocating engine aircraft in order to eliminate carburetor icing. So either alcohol spray and or heated induction air, meaning carburetor heat, can be used to eliminate carburetor icing. Now let's talk about structural icing forming on the aircraft. First of all, forming on the aircraft wing. Aircraft pneumatic de-icing refers to the boots on the leading edge of the wing and tail of the aircraft, and what they do is they remove ice accumulations, the boots do, by breaking up the ice physically, not by melting it off, but by inflating and expanding and physically breaking up the ice that forms on the leading edge of the wing and the tail. Now, the boots are inflated on alternate cycles. Different parts of the boots will be inflated at a time, and that alternate inflation cycle keeps the disturbance of the airflow to a minimum, because when you do inflate those boots, it will somewhat disturb the airflow over the wing. Now, where do you get the air pressure for to inflate those de-icer boots? Vane-type pumps are what is used as the source of pressure for inflating the de-icer boots on reciprocating engine aircraft, vane-type pumps. Now, in a pneumatic boot system, you need to know that what controls the inflation sequence is the distributor valve. They're going to throw all kinds of things at you, but in the pneumatic de-icer boot system, it is the distributor valve that is controlling that inflation sequence on the boots. During a normal operational check of the pneumatic de-icer system of the de-icing boots, what you should get is fluctuating readings on the pressure gauge because of the cycles that it's going through, but you should have relatively steady readings on the vacuum gauge. So you'd get fluctuating reading on the pressure gauge as it cycles and a steady reading on the vacuum gauge. What the vacuum is doing is that when the pneumatic de-icing system is off, when it's not in use, a suction relief valve regulates the vacuum off of the air pump, and that's what holds the de-icing boots deflated, keeps them deflated and holds them against the wing. And again, it is the distributor valve that directs the vacuum to those de-icing boots for the hold down in flight. So the distributor valve is a very important part of the de-icing system. Now, in order to protect the de-icer boots from oil deterioration, there is an oil separator in the system. And what that oil separator does is get rid of the oil and protect the de-icer boots from getting oil in them and being deteriorated by that oil. If you're going to be installing these pneumatic surface bonded type de-icer boots, one of the things you have to do is remove all of the paint from the area that's going to be covered by the de-icer boot in order to make sure that it's going to adhere properly to the surface. So be sure and remove all the paint from the area that's going to be covered by the de-icer boots. Now, if you need to clean de-icer boots, the way that you clean it is with soap and water. Soap and water can be used to clean the de-icing boots. Now, larger aircraft will tend to use thermal anti-icing instead of using boots. And what thermal anti-icing means is that they heat the leading edge of the wing to prevent the formation of ice rather than using boots to knock it off once it's already formed. So where do you get the heat from to heat the leading edge of the wing? Well, two possible sources of heat for that wing thermal anti-icing system are compressor bleed air from the engines and the aircraft electrical system. Compressor bleed air typically is pulled off of a backstage in the engine that gets it hot enough and with enough pressure to use to heat the leading edge of the wing. It's just ducted forward then and runs along the leading edge of the wing. With the aircraft electrical system, some aircraft will have electrically heated panels rather than bleed air heated panels on the leading edge of the wing, and then they're just using the aircraft electrical system to heat those electrical panels and prevent the ice from forming. What is not used for thermal anti-icing is exhaust gases or the air turbine cycle machine. Now, anti-ice systems like this that heat the leading edge of the airfoils, and also, by the way, they use them on the intake ducts for the engine, should be operated whenever icing conditions are first encountered or are expected to occur. These are anti-icing systems designed to prevent the formation of ice. They're not designed to get rid of it after it forms, so you want to turn it on as soon as icing conditions are very first encountered or if you expect to encounter them. Now, if you have combustion heaters providing the hot air, you're also going to have thermocycling switches. Thermocycling switches are what control the temperature of the anti-icing system when you're using surface combustion heaters, and what those thermocycling switches are simply cycling the combustion heater on and off as necessary in order to keep the air at the proper temperature. Now let's talk about the windshield. How we're going to prevent ice from forming on the windshield anti-icing. And there's three basic methods of anti-icing aircraft windshields. One of them is using windshield wipers and an anti-icing fluid. A second one is a heated air circulating system, in other words, blowing hot air on the windshield. And the third is an electric heating element in the windshield itself. And let's talk about the electric heating element style. The components that would be found in a laminated integral electrically heated windshield, like you'd typically find on, say, a 727, something like that. You're going to find an auto transformer, you're going to find a heat control relay, you're going to find a heat control toggle switch, and you're going to find an indicating light to tell you whether the heat is on or off, what the status is of the heat on the windshields. Now, on most aircraft that have electrically heated windshields, the heat sensors are actually embedded in the glass. The temperature sensing elements, the thermistors, are what is used to maintain the normal windshield temperature control when you have an electrically heated windshield system. So you've got temperature sensing elements that are actually embedded in the glass, and those temperature sensing elements are called thermistors, and that's what controls the temperature for the windshield heat. Now, if you have arcing in an electrically heated windshield panel, arcing usually indicates that you've got a breakdown in the conductive coating of the windshield. You've got a breakdown in the conductive coating that's allowing the electricity to arc on that windshield panel. Let's talk now about getting rain off of the windshield rain removal. One way to get rid of it is pneumatic rain removal. Pneumatic rain removal blasts air. Here are doors opening to blast air over the windshield to form a barrier that will prevent the raindrops from striking the windshield surface. So you can do, with a windshield pneumatic rain removal system, you're just simply blowing air, in this case, out these doors over the windshield to provide a barrier between the raindrops and the windshield. But on some windshields, you use a chemical rain repellent. And if you do use a chemical rain repellent, you never want to use it on a dry windshield, because on a dry windshield, that chemical rain repellent will actually end up restricting your visibility, causing you visibility problems when it's designed to solve visibility problems instead. Don't ever use the chemical rain repellent on a dry windshield. Now, another place that you find anti-icing is the pitot tube on the aircraft. The pitot tube actually has an electric heating element built into the pitot tube, and here are the electrical probes on that. The electrical heating element is built into the pitot head, and that's what's used to prevent ice formation on the pitot tube. And again, it is anti-icing. You want to turn it on before the ice has actually formed. One way to tell whether it's working properly or not is to read the ammeter in the aircraft, because the pitot tube heater really puts a load on it, and by reading the ammeter, that's one way to check to see if the pitot-static tube heater is operating properly, if you've worked on it or replaced it or done anything with it. Now let's talk about de-icing an aircraft on the ground. If you've got a lot of frost or snow on an aircraft, you can use a mixture of ethylene glycol and isopropyl alcohol in order to remove the frost. You can use that as a de-icing fluid to remove frost from an aircraft surface. Now, if what you've got is wet snow on the aircraft that you need to get rid of, the best way to get rid of wet snow is to use a brush or a squeegee and wipe it off. Going to be a lot more effective to use a brush or squeegee and basically just wipe it off of the aircraft. Sometimes what you can end up with is ice in a turbine engine. If you're getting ready to start a turbine engine, but there is ice inside it, you're going to have to melt the ice before you can start the aircraft, or else you're going to damage the engine. So what you use in that case is hot air to melt the ice in the turbine engine if the compressor is not moving, if it's immobile because of ice. So you're going to have to duct a source of hot air into that engine in order to melt the ice in it. You want to avoid damage.